Chapter 8 Test Review. Don't forget you can use an index card for your test tomorrow, one side only, but you can include anything on this test review that maybe you're still unsure of. Number 1, find the geometric mean. Remember, geometric mean means that x equals the square root of these two numbers multiplied together. So, if we write that out, this is what we get. 3 roots of 6 times 5 roots of 6. We have to figure out what that is first before we can take the square root. So remember, when you're multiplying radicals, 3 times 5 is 15, and 6 times 6 is 36, and that's under the square root. The square root of 36 is 6, so this becomes 15 times 6. Well, 15 times 6 is 90, so x equals the square root of 90, and we want to simplify that without making it a decimal. 90 is 9 times 10, so let's simplify this to 3 roots of 10. Number 2, to find the geometric mean, to find x, you need to use the geometric mean. So you can see here that the side length x is really 8 plus some other unit that we don't know to get the x. So the geometric mean of this side and this side is equal to 12. So we can simplify that a little bit. 12 equals the geometric mean of this piece right here, 8, times this piece. We don't know that, but we do know that the whole thing is 8 units, so we'll say x minus 8. To solve for x, first we need to get rid of the square root. So let's square the whole thing. 144 equals 8x minus 64. Let's solve for x. Add 64, and that gets you 208, so I'm going to come over here. Divide both sides by 8, and x is 26. That's how long that side of the triangle is. Number 3. Okay, first we need to know how long this whole bottom of the triangle is, which is 13. So remember our geometric mean. To find this, you need to use the side it's across from, which is 3, and the 13. X equals the geometric mean of 3 and 13. Multiply those together. And 39 cannot go any simpler, so that is our answer. Number 4. This time, we can just use Pythagorean theorem because I see a right triangle. So first I need to know what side is C. C is always across from the right angle. So I'm going to plug it in. 80 squared plus 30 squared equals x squared. Let's go ahead and evaluate those. $6,400 plus 900. That becomes 7,300. Now we want to know x, so we need to square root both sides. And then simplify if we can. I know right away, since there's 2 zeros, that there is 100 trapped underneath. So this becomes 10 roots of 73. Number 5. You should see a right triangle here. So if I pull that triangle out, I have 24x. Now how long is this side? It's not 24 anymore, it's only 12. So I can use Pythagorean theorem, but I need to know what side is C. C is always across from the right angle. So 24 squared equals x squared plus 12 squared. Let's go ahead and evaluate that. And let's simplify by subtracting 144 from both sides. And we get 432. So we've got to square root that. So I'm going to come over here. And I know that 432, 16 times 27, but this can go lower into 9 and 3. Here's a perfect square, here's a perfect square. So remember, it's just like saying square root of 16 times 9 times 3. So these two can come out as 4 times 3 times the square root of 3, which is just 12 roots of 3. That's how long my length of my triangle is. Okay, number 6, you're going to need special right triangles, so let's hopefully you remember. I have a square. Since all my sides are equal, all my angles are equal. If this is 90, this has to be 45 and this has to be 45. So I've got a 45, 45, 90 triangle, and my formula is x, x, x roots of 2. So what do I know? I know this side across from the 90 is 30. So that corresponds to the x roots of 2. So to solve for that, I'm going to make a little equation. Set those two equal to each other. 30 equals x roots of 2. To solve for x, let's divide by the square root of 2. And let's rationalize the denominator. So 30 roots of 2 over 2. And then we can simplify this part. 30 divided by 2 is 15. And there's our answer. Okay, number 17. AD is 14. Then the measure of angle D is 60. Find AF. Okay, that means that this is 60 and this is 90. I have a 30, 60, 90 triangle. My formula for that is x, x roots of 2, 2x. So I have this side right here, 14, which is across from the 90, which is your 2x. If 14 equals 2x, x equals 7. I want to find this side right here. Well, my formula says just take whatever x is and slap the square root of 3 onto it. So my answer is 7 roots of 3. And what side do I want to find? I want to find this side across from the 60. So this side right here. 7 roots of 3. Okay, for 8, you need to pull apart these triangles. Let's talk about this big triangle first. I'm going to redraw it so it has a little bit less stuff in it. I know that it's 90 degrees. I know this bottom side is y, and this is 8 roots of 3. And this is 30, which makes this 60. Okay? So, remember my formula? X roots of 3, 2x. If I write that out, this 8 roots of 3 corresponds to the x. Okay? How can I find this side? Well, it says take whatever x is and put the square root of 3 next to it. I can simplify that. Square root of 3 times square root of 3 is the square root of 9, which is a perfect square, which is just 8 times 3, which is 24. Okay, so if y is 24, what is x? So I'm going to draw this little triangle, or you could use this one, and I'm going to draw it over here. Let's use this big triangle. I know this is 24, this is 90, this is 30, which makes this 60. If you use this little triangle, you will get the same answer. It's just a little bit more complicated. So 24, I have a 30, 60, 90, my same formula, x roots of 3, 2x. 24 is across from the 90, so 24 is 2x. If 24 is 2x, x is just 12. What side do I want to find? I want to find the side across from the 30, which is right there, the x. So x equals 12. Okay, number 9. For number 9, you need to remember SOHCAHTOA. Okay, I am looking at this angle right here because it's what I know. I know the adjacent, and I know the height, and I want to find the hypotenuse. So that is cosine, adjacent hypotenuse. So the cosine of my angle equals the adjacent over the hypotenuse. So let's solve for x. Let's multiply both sides by x. And we get x times the cosine of 16 equals 8.3. Let's divide by the cosine of 16. And x equals 8.3 divided by the cosine of 16. Go ahead and put that in your calculator. And it says to round to the nearest tenth. So you will get about 8.6. Alright, number 10. A-frame house, 45 feet high. You want to find this angle. So the height is actually talking about this. So if I draw this as a right triangle, how long is this part? It's not 32 anymore. It's actually just 16. So when I find x, think about SOHCAHTOA. I know the opposite and I know the adjacent. That sounds like tangent. So the tangent of my angle equals the opposite over the adjacent. Remember, when I want to find the angle, use inverse tangent. So inverse tangent of 45 over 16 equals, and it says round to the nearest degree. Yes, 70 degrees. Excelente. Okay, number 11. Let's draw this out. Let's draw our little tree. And it's 38 feet. And it casts a shadow that is 16 feet. And the measure of angle of elevation, that's this angle down here, of the sun to the nearest degree. So this right here makes a triangle. Here's my right angle. And I want to find x. So look at my sides I have. Am I going to use sine, cosine, or tangent? Yeah, I'm going to use the tangent. don't know the angle, but I know the side opposite and the adjacent. So remember, inverse tan, 38/16, round to the nearest degree. So the angle is about, not 16. Your teacher cannot read apparently. 67 degrees. Number 12. Let you read it. Angle of depression, remember that's talking about this angle right here, which makes this angle down there 10. So again, sine, cosine, tangent, going to use tangent. Again, tangent of 10 is x over 2,000. Let's do a little rearranging, a little algebra, multiply both sides by 2,000. And we get 2,000 times the tangent of 10 equals x. It says to round to the nearest tenth. So go ahead and put that in your calculator. And you will get about 352.7. Now, because it's a word problem, we need to label it meters. Okay, number 13. A plane flying at an altitude of 10,000 feet. So here's my plane. Altitude means height. So this is 10,000 feet high. And it begins a descent, so it's going down. And the runway is 60,000 feet away. I want to find the measure of the angle of descent, that's this right over there, to the nearest degree. Again, I'm going to use tangent. Tangent is going to be your best friend. The tangent of x of 10,000 over 60,000. Now, remember, you can also simplify. So for sake of putting it in my calculator, I'm going to put in my calculator the inverse tangent of 1/6. And it says round to the nearest degree. (9 degrees). So not too steep. Alright, number 14. To solve for x, ask yourself, do you have a right triangle? Since the answer is no, you cannot use Pythagorean theorem. You cannot use SOHCAHTOA. You have to use law of sines. Now, to use law of sines, you do need to find this missing angle. So let's do a little math. 180 minus 68 plus 42. We'll find that angle is 70 degrees. Law of sines, remember, says take your angle and your side opposite, make a proportion. Okay? So the sine of 70 over x, its corresponding side, equals the sine of 42 over 23. Let's cross multiply. To make an equation, and to get x by itself, we have to detach the sine of 42. It's multiplying, so let's divide by sine 42. Alright, so in your calculator, let's put that in. Let's put in 23 sine of 70 divided by the sine of 42, and it says round to the nearest tenth. 32.3. Excellent. That represents how long that side is. Okay, Go ahead and turn the page. We are almost done. 15. Find x. So again, I'm going to use law of sines because I have right here a nice little proportional relationship between my sides and angles. So the sine of x over 6 equals the sine of 38 over 17. Let's cross multiply again. Okay, how can I get x by itself? First, let's get rid of the 17. Okay, now since I have the sine of x and I want to find the angle, remember, want to find the angle, do the inverse. So, inverse sine of this whole thing. 6 sine 38 over 17, and it says round to the nearest degree. So when you put it in, you'll get 12.5. So round that up to 13 degrees. Number 16, we're going to use law of sines again. Now remember, proportional relationships, 14 and x, and 60, and I don't know that side, so I got to find it. 180 minus 14 plus 93 equals 73. Okay, let's put it in our equation. The sine of 14 over x equals the sine of 73 over 60. Cross multiply again. 60 sine 14 equals x sine 73. Divide both sides by the sine of 73. And we get round to the nearest tenth. So in our calculator, 60 sine 14 divided by sine 73. It's about 15.2 feet. That's about how tall that tree is. Okay, law of cosines is what we have to use for 17. How do I know? Because if I were to make a proportional relationship, I don't have one. I only have one relationship between this angle and that side. So I'm going to use those to know how to plug in my law of cosines. Law of cosines says take this relationship here and the side, square it, and it equals the other two sides squared, 9 squared plus 16 squared, minus 2 times the product of those sides, 9 and 16, times the cosine of our angle that was across from it, x. Let's go ahead and simplify all of our squareds. 64 equals 81 plus 256 minus 288 times the cosine of x. Now, how can I simplify this right side? Well, I can go ahead and add these two together and get 337. Remember, you cannot subtract it by 288 because it goes with the cosine. Let's subtract 337. And we get negative 273 equals negative 288 times the cosine of x. It would help if you could see it, huh? Sorry. Divide by negative 288. And the cosine of x equals that, so we want to find x. So we're going to do the inverse of that whole little ratio, 273 over 288. And it always round to the nearest degree. About 19 degrees.